we developed data wrangling pipelines that rearrange the original data retrieved from the data providers so that they can fit a common data schema in the EnerMaps database. As the original data comes from the data providers in different formats and with different schemas, several transformations are conducted by the pipelines we have developed. So the content of the books doesn't change, but the way the books are indexed and organized in the shelves does, as they are part of a single library now, that is the EnerMaps database. The pipelines are developed as Python scripts that can be periodically run to check for new updates, should the new data be available and consistent with the original schemas. Existing pipelines can be also used as a template to develop new ones and add new datasets, and this is important for future developments of the platform. The calculation modules allow the user to run a calculation based on datasets present in the EnerMaps database and a few other inputs. In this way, the user can create new data that is not originally present in the EnerMaps database. This is normally done for a specific area of interest, let's say a city or region, which can also be selected or drawn in the web platform. The backend then takes charge of the calculation itself, which is usually run in a few seconds. And then the results are returned and visualized to the user, usually in the form of a map, but possibly also with graphs and summary statistics. It's also possible to download the results to visualize them with a desktop software. The input parameters are shipped with the results, so that we always know how we got to that result. I think that calculation models are very useful to bring scientific models applied to the datasets of the EnerMaps database to the general public. Artificial intelligence was used as part of the hit-learn calculation module. The idea was to show the benefit of a platform like EnerMaps to deploy a calculation module that is not based on a traditional physical or engineering model, but rather on a data-driven approach. Training a data-driven model is often a complex and time-consuming process. We wanted to show that deploying a data-driven model within the EnerMaps platform is rather quite easy, so that data scientists can focus on the model development rather than on its deployment. For the end user, the advantage is that an AI model can be usually run much faster than a traditional model. In this way, they can have the results returned in the web platform in a few seconds and are able to run multiple scenarios.